Today, I'd like to discuss what is the probability. Well, in our real life, there are many events which occur frequently or carried out. For example, a machine produces product repeatedly at a production plant. The product can be either normal or defective, but we don't know what it will be. Or we can order pizza at home every Sunday. It usually takes 30 minutes for a delivery of a pizza, but we don't know exact time. We call this kind of thing is a statistical experiment. What are the characteristics? Similar event is repeated. Okay? A machine produces a product. Pizza is delivered. Various possible outcomes are known. Well, we can say the product can be either normal or defective, or any time between 10 to 30 minutes. Various possible outcomes are known, but we don't know exactly what will happen. We call some statistical experiment which satisfy this kind of property as a statistical experiment. Then what is non-statistical experiment? Typical example is what will be the headline news tomorrow newspaper. Can you specify that? There are too many. We cannot specify all possible headline news. That is not the area of application of statistics. Statistics can only apply to statistical experiment. In case of a statistical experiment, we call the all possible outcomes sample space. Usually we denote it as by S, like normal and defective, but we classify two categories. Depending on how many elements in the sample space, it can be discrete and continuous. It implies there's a countable number of elements, continuous cases, uncountable numbers. A subset of this sample space, we call it is event. We denote it as capital letter like this. Then what is probability? Probability is a representation of likelihood of an event between 0 and 1. If an event is likely, the probability is close to 1. It is unlikely, it is close to 0. There are two definitions, but usually we are using classical definition. But in order to help you understanding, we introduce relative frequency definition. Classical definition of probability like this. We assume all elements in the sample space are likely to occur equally. In most of the cases, I think this kind of assumption is right, is okay, I say. Then how can you calculate the probability? In case of a discrete sample space, we count total number of elements in sample space and then count the number of elements belong to event A. If it is a continuous sample space, then we measure about the sample space and then we measure about event A. We take a ratio as a probability. The measurement can be length, area, volume, etc. Let's consider one simple example. An office worker went on a business trip and he's hesitating which restaurant he'll go. He decided to throw a dice and then count the number of points. If it is odd numbers, go to restaurant A. If it is even numbers, go to restaurant B. What is the probability that restaurant A would be picked? Well, sample space can be denoted as like this. The number of odd events, you can say it is set 1, 3, 5. Therefore, probability is count the total number of elements in the sample space and find the ratio of the number of elements in the event. That is 3 out of 6. How about another example? You order pizza. Suppose you assume pizza delivery time is in between 10 to 30 minutes. What is the probability it delivered between 20 and 20 minutes? 25 minutes? We denote a sample space in this manner as a set, I mean some number between 10 to 30. What is the event the pizza delivered in these minutes? We just denote it as a set, 20 to 25. Therefore, probability is just measure the distance of this sample space and then the event. It looks like this, 25 minus 20, 30 minus 10. This ratio is 1/4 will be probability of this event. I mean, delivered between 20 and 25 minutes. There's another definition, relative frequency. Why it comes? Based on classical definition, there are some situations which cannot explain. For example, if you toss a coin, it can be either head or tail. But very rare situation, it cannot stop. It's in the middle, it's in the edge. In order to represent that kind of situation, they propose use just doing experiment and then count number of event belong to this category. If you go to EastU, there's one simulation. It's a flip a coin and maybe 1,000 times, and it shows that as the sample size grows, it converges to half. That means in most of the cases, the relative frequency definition is converged to approximately to classical definition. Okay, this is the definition of probability. Next class, we're going to discuss how to calculate probability. See you on next lecture.